In continuation of our discussion about three-phase power, we do briefly have to talk about a problem you see occasionally in some commercial buildings. It's called three-phase phase unbalance. So a full three-phase power supply is recommended for all three-phase motors. It consists of 3 individual transformers or 1 three-phase transformers. Delta or Y connections using only 2 transformers can be used, but are more likely to cause problems such as poor performance, overload tripping, or early motor failure due to current unbalance. Now, you don't see this in newer buildings. This is mostly seen in older and older construction. So the first thing you want to do when you turn on any three-phase equipment is establish the proper direction by running the motor momentarily and observing the blade direction or the pressures from the compressor. Rotation can be changed by swapping 2 of the line power leads. Make sure you turn off the power before doing this. That's extremely important, and make sure you verify it's off because you're going to be handling the high voltage. So anytime you start a piece of equipment, always just momentarily start it to make sure everything's turning in the right direction. After correcting the rotation, check the current draw on all 3 of the motor leads and calculate the current unbalance. And the next slide will show how to do this. If the current unbalance is 2% or less, leave it as is, you're fine. So to calculate the percentage of current unbalance, add the 3 line amp values together. Divide the sum by 3, and that you get the average current. Pick the amperage value which is furthest from the average current. It's either high or low, and determine the difference between this and the amp value furthest from the average and the average. In other words, you're going to find the difference between the average amp value and this one. Divide the difference by the average, multiply the result by 100 to determine the percentage of unbalance. Okay, so again, you want to take the 3 values, add them together, divide it by 3. That's your average. Find the amperage value that is furthest from the average. Okay, it's either going to be high or low. Ignore the sign, positive or negative, doesn't matter. Determine the difference between that and the average. You're going to subtract the 2 numbers. Divide that difference by the average, multiply it by 100. You'll get your percent of unbalance. Then what you do is you can actually change the hookups around. So we start off with L1, L2, L3 connecting respectively to T1, T2, T3. Change it. Swap your leads around. Okay, so L1 goes to T3, L2 goes to T1, L3 goes to T2. Calculate it again. Swap your leads around a 3rd time if you have to, and calculate it again. So once you've done that 3 times, okay, once you have your 3 numbers, find out which is the closest, okay? So this, they basically measured 51 amps, 46 amps, 53 amps, 150 amps, okay, is my average, or add it all together. My average is 50, okay? So we take and we swap the leads around, and we take the furthest away from that average, okay, either high or low, okay, and we come up with that. Then we divide that number by the average. Okay, and we find out that our second position, okay, where the second position, which is this one right here, gives us our best percentage. It has a 2%. Well, 2%, I'm fine. I'm within the limits. So current unbalance should not exceed 5% at the max load or 10% at rated input load. Okay, but again, remember, if 2% comes up, I'm fine. If the unbalance cannot be corrected by turning the leads, by rolling the leads, in other words, repositioning the leads, the source of the unbalance has to be located and corrected. It could be the power side or the motor side. You'll need to determine this. To double check the motor side, disconnect the motors and ohm out each of the motor windings. Okay, if the motor windings are not identical resistance on a 3-phase motor, you have a problem with the motor, okay, and you have to contact the manufacturer, especially with new equipment. If the motor ohms out properly and if everything else ohms out properly, it's on the power side. Contact an electrician. There's not much you can do with it. Some manufacturers have phase unbalance protection in their light and heavy commercial units that constantly monitor the phase unbalance of a unit, and it's going to shut the machine down if it goes past the limits. There's safeties on this to make sure that they don't go past the limits. So again, it's not something you see very frequently, but it's something you should keep in mind if you start having motor problems and lockouts on commercial equipment. You don't see this in residential or light commercial if it's only single phase power.